The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Welcome back. Hope you all are doing well. Do your work on time. Don't be lazy. Okay. In the previous class, we have discussed on refraction and what happens when a light ray travels from a denser medium to a rarer medium or from a rarer medium to a denser medium. And we have also discussed on the laws of refraction. So today we will discuss about refractive index. Okay, so in the previous class we have discussed on the laws of refraction, and in that I told you the value of sin I by sin r is a constant, and that constant is known as refractive index. Clear? Sin I by sin r is a constant and that value is known as refractive index. Now, tell me whether this refractive index has any relation with the speed of light. Let's see the formula for refractive index of a medium with respect to air. The refractive index is denoted by the letter N, and let's see how to find out the refractive index of glass with respect to air. Okay, refractive index is denoted by the letter N, and we are going to find out the refractive index of glass with respect to air. So N is equal to speed of light in air divided by speed of light in glass. Okay, speed of light in air by speed of light in glass. And you know the value of speed of light in air. How much is that? 3 into 10 raised to 8 meter per second by, what is the speed of light in glass? 2 into 10 raised to 8 meter per second. Okay, 10 raised to 8 and 10 raised to 8 get cancelled. So what is remaining? 3 by 2. What is 3 by 2? It is 1.5. So the refractive index of glass is 1.5. So I hope you understood how to find out the refractive index of a medium. Okay, so suppose if you want to find out the refractive index of water, how will you find out? Speed of light in air by speed of light in water. Is it clear? Next is relative refractive index. What is relative refractive index? This is a refractive index of a medium with respect to another. Where medium item nammal relate cheyana. That is known as the relative refractive index. Once again, relative refractive index is a refractive index of a medium with respect to another. Is it clear? Now, the next one is absolute refractive index. Absolute refractive index is a refractive index of a medium with respect to vacuum. Okay, that is air or vacuum aayittaanu nammal compare cheyanannundengil, that is known as the refractive index or the absolute refractive index. Is it clear? So what is absolute refractive index? It is a refractive index of a medium with respect to vacuum. This absolute refractive index is normally known as the refractive index. Okay, and it is denoted by the letter Nm. Now, if the speed of light of air is denoted by the letter C and the speed of light in medium is represented by the letter V, then how can you write the formula for absolute refractive index? Absolute refractive index is equal to speed of light in air divided by speed of light in medium. Okay, and I told you speed of light in air is represented by the letter C and speed of light in medium is represented by the letter V. So we can write Nm is equal to C by V. Okay, this is the formula to calculate the absolute refractive index, and this absolute refractive index is normally known as the refractive index of the medium. Okay, so you have to study relative refractive index and absolute refractive index properly. Okay, so shall we do one problem? Now let's find out the absolute refractive index of water. Okay, so how will you find out the absolute refractive index of water? Speed of light in air divided by speed of light in which medium? In water. Okay, this is how you have to find out the absolute refractive index. So what is the speed of light in air? It is 3 into 10 raised to 8 divided by, what is the speed of light in water? 2.25 into 10 raised to 8. So this 10 raised to 8 and 10 raised to 8 get cancelled. That is 3 divided by 2.25, which is equal to 1.33. So this is how you have to find out the refractive index. And this refractive index is also known as the absolute refractive index. Clear? Next topic is total internal reflection. Total internal reflection. So, what is total internal reflection? Already reflection we have studied in the previous chapter, isn't it? This is total internal reflection. And see, there is a barcode given in your textbook. Scan that and you will find an experiment. Okay, so in that experiment, when a laser is shown to a beaker of water, as the angle of incidence changes, the angle of refraction also changes. Right? The angle of incidence മാറുന്നതനുസരിച്ച് angle of refraction മാറിക്കൊണ്ടേയിരിക്കുന്നുണ്ട്. Okay, so watch that experiment carefully. Now, see, here the light ray is traveling from a denser medium to a rarer medium. Listen, if a light ray is traveling from a denser medium to a rarer medium, what will happen to that light ray? It will move away from the normal, isn't it? So when a light ray is traveling from a denser medium to a rarer medium, it moves away from the normal. And this angle is known as the angle of incidence, and this is the angle of refraction, isn't it? So as the angle of incidence increases, what happens to the angle of refraction? The angle of refraction also changes, isn't it? As the angle of incidence changes, the angle of refraction also changes. And at a particular angle of incidence, we can see the refracted ray moves along the surface of separation. അതായത് ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് മാറുന്നതനുസരിച്ച് ആംഗിൾ ഓഫ് റിഫ്രാക്ഷനും മാറിക്കൊണ്ടേയിരിക്കും. ഓക്കെ, അല്ലാതെ ഒരേപോലെ ആയിരിക്കില്ല റിഫ്രാക്ട് ചെയ്ത് പോവുക. ഇൻസിഡൻസ് ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് മാറുന്നതനുസരിച്ച് ആംഗിൾ ഓഫ് റിഫ്രാക്ഷൻ മാറും. And at a particular angle of incidence, we can see the refracted ray moves along the surface of separation. Okay, ഒരു പെർട്ടിക്കുലർ ആംഗിളിൽ മാത്രം എന്ത് സംഭവിക്കുന്നുണ്ട്? That refracted ray moves along the surface of separation. At that time, the angle of refraction will be 90 degree. Okay, that particular angle of incidence, this angle of incidence is known as critical angle. Okay, it is known as critical angle. So what is critical angle? When a light ray moves from a denser medium to a rarer medium at a particular angle of incidence, what will happen? The refracted ray moves along the surface of separation. So the angle of incidence in the denser medium for which the angle of refraction is 90 degree is known as critical angle. So there is a condition for that. The light ray should travel from denser medium to a rarer medium. Okay, only then it will move away from the normal. As the angle of incidence changes, the angle of refraction also changes, and for a particular angle of incidence, for a particular angle of incidence, what happens? The refracted ray moves along the surface of separation. The refracted ray moves along the surface. Okay, so the angle of incidence, this is the denser medium. This is the rarer medium. Isn't it? So the angle of incidence in the denser medium for which the angle of refraction is 90 degree is known as critical angle. Is it clear? For glass it is 42 degree. Okay, critical angle of glass is 42 degree. Suppose if the light ray is traveling from glass to air, ഈ ആംഗിൾ 42 ഡിഗ്രി ആവുമ്പോഴാണ് എന്ത് സംഭവിക്കുക? റിഫ്രാക്റ്റഡ് റേ അതിൻ്റെ സർഫസിൽ കൂടെ റിഫ്രാക്റ്റ് ചെയ്ത് പോവുക. whereas for water it is 48.6 degree. Okay, for water that angle should be 48.6. Only then the refracted ray moves along the surface of separation. Clear? What is critical angle? Now, what happens when the angle of incidence becomes greater than the critical angle? This angle becomes greater than the critical angle. Critical angle ne kaattlum koodiya. What will happen? The light ray, instead of undergoing refraction, all the light ray reflects back to the denser medium itself. Okay, so that process, that phenomena is known as total internal reflection. Once again, when a light ray moves from a denser medium to a rarer medium, or in other words we can tell, if a light ray moves from a higher optical density medium to a lower optical medium, what happens? If the angle of incidence becomes greater than the critical angle, what happens? The light ray reflects back to the denser medium itself without undergoing refraction. This is known as total internal reflection. Clear? So what is the condition for total internal reflection? That is, the light ray should travel from denser to rarer medium. That is the first condition. Okay, and the second condition, angle of incidence should be greater than the critical angle. Okay, if these two conditions are there, that phenomena is known as the total internal reflection. So when a ray of light passes from a medium of greater optical density to that of lower optical density, the angle of incidence at which the angle of refraction becomes 90 degree is the critical angle. The critical angle in water is 48.6 degree. Next is total internal reflection. When a ray of light passes from a medium of higher optical density to a medium of lower optical density at an angle of incidence greater than the critical angle, the ray is reflected back to the same medium without undergoing refraction. This phenomena is known as total internal reflection. So I hope critical angle and total internal reflection is clear for you. Okay, next we will see the uses of this total internal reflection. Now let's see the uses of total internal reflection. Total internal reflection is used in medical field. Okay, that is in endoscope this total internal reflection is used. You might have heard of endoscopy, isn't it? So there this total internal reflection is made use of, and in the field of telecommunication, that is in the optical fibers, this total internal reflection is made use of. So what is happening there? It is used in optical fiber cables. So thousands of signals can be sent to distant places without losing its intensity. This paved the way for optical fibers being used in telecommunications. Okay, so we can send the signals to distant places without losing its intensity. Okay, so find out more examples or find out more uses of total internal reflection and note down in your file. Clear? Next, we will move on to the next topic, lenses. Lens. This word is familiar to you, right? What is lens? Is it a transparent medium? Yes. Lens is a transparent medium bounded by spherical surfaces. Okay, lens is a transparent medium bounded by spherical surfaces. There are two types of lens, convex and concave. Okay, convex lens and concave lens. A lens which is bulged outwards is known as a convex lens. A lens which is bulged outwards is a convex lens, and a lens which is curved inwards is a concave lens. Is it clear? So what is lens? Transparent medium bounded by spherical surfaces. Two types of lenses, convex and concave. Now we will study some terms related to these lenses. Now convex and concave lens. See here, convex lens, isn't it? Look at the central part. This is a convex lens. Look at this picture. Here you can see a convex lens, isn't it? And here two spherical surfaces are kept and the middle portion acts like a concave lens. So we can tell convex and concave lens, they are a part of a spherical surface. And what will you call the midpoint of that spherical surface? It is known as the center of curvature. Okay, so we can tell what is center of curvature? Center of curvature is the center of the sphere of which lens is a part. Okay, this sphere is a part of lens. അപ്പോൾ സെൻറ്റർ ഓഫ് കർവേച്ചറിനെ നമുക്ക് എങ്ങനെ ഡിഫൈൻ ചെയ്യാം? സെൻറ്റർ ഓഫ് കർവേച്ചർ ഇസ് ദ സെൻറ്റർ ഓഫ് ദി സ്ഫിയർ ഓഫ് വിച്ച് ലെൻസ് ഇസ് എ പാർട്ട്. ഓക്കെ, ഇതിൻ്റെ ഒരു പാർട്ടാണ് ലെൻസ്. അതേപോലെ ഇതിൻ്റെയും ഒരു പാർട്ടാണ് ലെൻസ്. That is the first point. Center of curvature is the center of the sphere of which lens is a part. Center of curvature. Second one, optic center. All these things are familiar to you while studying reflection of light. isn't it? What is optic center? Midpoint of the lens is known as optic center. Midpoint of the lens is known as optic center, denoted by the letter P. Okay. What will you call? This is a center of curvature. What will you call the line that is passing through the center of curvature and the optic center? It is known as the principal axis. Principal axis. So what is principal axis? The line passing through the middle of the lens, or the line joining the center of curvature and the optic center is known as the principal axis. Principal axis is the imaginary line that passes through the center of curvature and the optical center. Principal focus. Principal focus. How will you find out the principal focus? That is, you know, lens is a transparent medium. This is the optic center, center of curvature. So what happens when light falls on this lens? The light ray gets transmitted. Lens adine kadatti vidum. So what happens? The light that is falling on the lens, after refraction, they meet at a particular point on the principal axis. Okay, the light ray that is passing through the lens, after refraction, they meet at a particular point on the principal axis. That is known as the principal focus. Is it clear? So, can you tell me how many principal foci does a convex lens have? ഒരു സൈഡിൽ നിന്ന് മാത്രമാണോ ലൈറ്റ് വന്നിട്ട് ആ ലെൻസിൽ വീഴുന്നത്? അല്ല അല്ലേ? Look at this picture. Center of curvature. The light ray that is passing through the lens, after refraction, they meet at a particular point on the principal axis. See here, light enters the lens through either sides, and we can say there are two principal foci for a convex lens. So what is principal focus? The light ray that is passing through the lens, after refraction, they meet at a particular point on the principal axis. That particular point is known as the principal focus. And there are two principal foci for a convex lens. And the next one is focal length. Focal length. It is the distance from the optic center to the focus. The distance from the optic center to the focus is known as focal length and represented by the letter F, small letter F. Clear? So, in the same way, how many principal foci does a concave lens have? Or how will you find out the focus of a concave lens? Now, let us see the case of a concave lens. Here also, the light ray that is falling on the lens, after refraction, it diverges as if it is coming from the focus. So these refracted rays, they are extended back such that it meets at a point on the principal axis. That particular point is known as the principal focus of a concave lens. The same way, the light ray that is entering from the other side also, what happens? The light ray diverges as if it is coming from the focus. So we can tell the principal focus of a concave lens is virtual. We cannot see. Okay, whereas the principal foci of a convex lens is real. Understood the difference between the principal focus of a convex lens and concave lens? For a convex lens, the principal focus is real, whereas for a concave lens, it is virtual. Light rays incident parallel and close to the principal axis after refraction converges to a point on the principal axis of a convex lens. This point is the principal focus of a convex lens. Light rays incident parallel and close to the principal axis diverge from one another after refraction. These rays appear to originate from a point on the same side. This point is the principal focus of a concave lens. And the principal focus of a concave lens is virtual. Why is it called virtual? Because it is impossible to produce real convergence of light using a concave lens. Therefore, the principal focus of a concave lens is virtual. So, what all things we have discussed today? We have discussed on relative refractive index, absolute refractive index, and total internal reflection and critical angle. And we have also discussed on lenses, different types of lenses, and some terms related to the lens. Okay, so go through the class, read the text after that. Call me if you have any doubts. Okay, see you all in the next class with a new topic. Bye.